You may have heard conflicting theories on whether the Earth's rotation is speeding up or slowing down. Recently, there has been a slew of articles informing us that it is speeding up, yet some sources, like this recent video from Voyager, suggest it is slowing down. So which one is correct? Well, both. Let me explain. Since the formation of Earth from a cloud of gas and dust 4.5 billion years ago, many factors have had an influence over Earth's rotational speed. As stated in Voyager's video, the longest standing and most significant of these is the Moon's gravitational pull on the Earth, which we can witness for ourselves through the tidal rise and fall of our oceans. This effect has been gradually slowing the Earth's rotation for billions of years, so much so that around 300 million years ago, an Earth day would have only been 22 hours long. So why all the talk of Earth's rotational speed increasing? As stated earlier, many factors play a part in Earth's eternal pirouette around the Sun. Everything from the mass pumping of groundwater to earthquakes and even activity within Earth's molten core have always created a slight variance in Earth's rotation. But in recent years, Mother Earth has been in a hurry. So much so that on June 29th, 2022, Earth completed the shortest day since scientists started keeping records in the 60s. 1.59 milliseconds faster than usual. There are several theories on why this is occurring, one of which has to do with the Chandler wobble. First discovered in the 1800s, this refers to the not quite perfectly round Earth wobbling as it spins, not unlike a child's spinning top. This wobble mysteriously disappeared between 2017 and 2020, and it is believed by some that this may have attributed to the Earth's rotation speeding up. Judah Levine, a professor at the University of Colorado Boulder and longtime expert at the National Institute of Standards and Technology, shared some insight into the phenomenon in an article from Inverse.com. He believes that another theory that explores the melting of glaciers playing a part in the shift is unlikely, as this should have the opposite effect, as the planet's moment of inertia would increase, which would in turn slow us down. Levine believes the likely culprit is the exchange of momentum between the Earth and the atmosphere, and is quoted as saying, "The sum of those two is a constant," which means, for example, if the atmosphere slows down, then the Earth speeds up. Or conversely, if the atmosphere speeds up, then the Earth slows down. He then goes on to explain, the same thing can happen deep inside our world. It's possible for the deep core and the mantle, the large layer that exists between the core and the surface, to move at slightly different speeds. There could be an exchange of angular momentum between the Earth's deep core and the mantle. However, at present, there is no possible way to pinpoint a singular cause for the increase in speed. Despite Earth's increased rotational speed in recent times, it is widely acknowledged that this is likely to be merely a momentary variation on a galactic scale, and Earth's rotation will continue to slow down over the coming millennia, meaning as time goes on, the days will only become longer.